Good afternoon everyone, or so good day everyone kung anong oras man ito pinapanood. So, static of rigid bodies. So, this is a recorded video, so pwede nyo balikan once namin tanong kayo. And nag-set naman din ako ng synchronous classes natin. So, for those students na hindi nakapag or hindi naka-attend ang synchronous class natin, so baka lang yan. So, recorded naman itong video and explain na lang kung ano yung module 1 natin. And then, so let's start. No, bago pa tumagal yung video. So, module 1, no, Introduction to Mechanics, Vector Operations. Okay, so, branch siya ng engineering mechanics to yung mechanics of rigid bodies, sa branch of engineering mechanics, and mechanics of rigid bodies, natin siya sa dalawa, which is statics and dynamics. So, guys, focus tayo sa statics, no? Since it's about statics of rigid bodies. Okay, so meron na naman tayong mechanics of deformable bodies and mechanics of fluids. So, ang mechanics of deformable bodies, no, sa structures niyan, no, sa fourth year yung nakitakan niyan. And then, mechanics of fluids, no, yan, parang sa ating aerodynamics na. So, balik tayo mo, mechanics of rigid bodies, which is statics. So, statics, natin sa dalawa. We have four systems and natin siya tatlo, no, four systems. We have concurrent, parallel, and non-concurrent. Actually, may isa pa yan, which is complanar. No? So, later on, pali-discuss natin yan. So, application of statics, no? Sa trusses, centroids, and frictions. So, dynamics naman, kinematics, and kinetics. So, dynamics, no? Motion. Dito sa statics, wala. I mean, sa equilibrium state tayo. No? Sa statics. Dito sa dynamics, no? May force and motion din. And then, later on, no, sa ibang sa next sem, tatakan yung dynamics. So, statics muna tayo. Okay, statics, no? Consider the effects and distribution of forces on rigid bodies which are and remain at rest. So, yun lang yung ng statics, no? Main idea yan, no? Sa at rest tayo, sa equilibrium state tayo. While dynamics consider the motion of rigid bodies caused by the force and acting upon them. So, yun ang dynamics natin, motion lang siya. Statics, wala. Or at rest tayo. So, that's the main concept lang ng statics and dynamics. So, naglagay lang din ako dito ang kinematics and kinetics, which is kinematics deals with pure motion of rigid bodies, while kinetics relates to motion to applied forces. Okay? And then, what is mechanics? So, mechanics is a branch of physical sciences associated with the state of rest or movement of objects subjected to force action. So, nahati din yan, no, ang mechanics natin. Katulad ng sinabi ko kanina, we have rigid body mechanics, we have deformable body mechanics, and fluid mechanics. So, in rigid body mechanics, it is important for the design and study of several types of rigid structures, mechanical systems, or electrical equipment. So, rigid body mechanics is broken down into two areas, which is static and dynamic. So, yun yung pinakita ko kanina sa inyo, no, natin ang mechanics of rigid bodies natin. So, static deals with the equilibrium of bodies that either stop or travel at a steady velocity, while dynamics deals with the rapid acceleration of body. So, may motion tayo sa dynamics, sa statics, wala. So, ulit, no? Yun lang yung concept nun, statics and deformable. Fundamental concepts, so basic quantities, no? Kung ano length. So, length is basically the body, distance, and geometric properties, no? As multiples of this unit. So, yung mga meter nyo, feet, length, meter, foot, no, yard. So, iba't ibang dimensions or geometric properties. Well, time is thought as a series of events. No? Although the statics rules are separate from time, this quantity plays an important role in the theory of dynamics. So, na-apply kasi natin kasi may motion tayo doon. Mass is a calculation of amount of matter used to equate one body's favor to that of another. So, mass, no, kung ano yung, kumbaga, kung anong, ano yung matter mo, kung ano yung molecules mo sa katawan mo, di ba parang ganun, ang mass, okay? So, times lang yun sa gravity to have your weight or your force, di ba? So, force is general force is known as a push or pull that one body exerts on another, no? This movement can occur while the bodies are in a close contact, such as a person leaning on the wall, or when the bodies are physically apart, may occur across a gap. So, force, no? Simply force nyo lang naman is your force to mass times acceleration, di ba? So, yan lang yung force nyo, di ba? And this is your mass. Mass nyo. Okay? Next is, um, idealization sa rigid body. So, particle. A particle is a mass that can be ignored in direction. If a body is idealized as a particle, the rules of mechanics are condensed to a very simplistic form as the body geometry would not be included in the problem study. So, hindi natin sinasama yung uh, yung mass na yun, no, sa atin. Kasi nga, focus lang tayo, no, sa equilibrium state, no, sa property ng structures natin. So, hindi pa siya na-apply, kumbaga force pa lang tayo. Okay, so rigid body may be described as a mixture of a large number of particles in which all the particles remain at a set distance from each other. And this model is important because the form of the body does not change when adding a load. So, kahit nag-apply ka dyan, hindi pa nag-deform yung structures mo, di ba? So, kinukompute natin is yung equilibrium state ulit and yung steady or at rest na component natin sa ating structures. No? And then, for concentrated forces describe the influence of a charge may be acting on the body at a point. So, we may reflect a load by a focused force provided that the area where the load is applied is very limited compared with the total body size. So, concentrated force, no? So, basically lang siya kung saan siya natututok yung force mo, kung saan siya papunta, no? Kung saan siya in-apply yung concentrated force. So, here, sa structures natin, no? Sa statics of rigid bodies, yun yung mga elements, no? Be considered dito. Kasi may mga ano yun kumbaga may mga neglected like the type of structures, kung anong type siya, like aluminum or copper ba siya. No, dito, hindi pa siya napapansin kasi nga hindi pa natin inaalam, no? Kung magde-deform ba or masisira ba yung structures, and ganyan. So dito, equilibrium state lang and at rest. Okay? Next is system of units. So, important ang system of units to identify, no, kung para maging formal or iisa sa sagot mo or kung ano yung forces na mag-come up. No? So, we have two systems. We have SI units or metric, then we have English unit or imperial units. Okay? So, SI units, no, or meter units, metric is meter second kilogram Newton, while no, the English system is foot, seconds, log, pounds, ganun. Okay? So, basic lang yan, no? Recall lang, no? Sa physics natin, sa trigonometry natin, no? Then, next is prefixes. So, sa solution kasi, no, ng static stated bodies, no, may ako-consider din na kumbaga lagpas yung force mo sa maraming numbers. So, in here, no, shortcut natin yun using prefixes. Okay, actually, lumabas sa board exam, no, lumabas na dito is yung 10 raised to negative 6 micro. Yeah. So, basic lang yan. No? Recall, hindi ko alam kung statistics ba, no? Practices. No? Kasi di ba, madaming numbers nun. So, try to memorize lang din, no? Or to recall kung alam mo naman to. Okay? Next is numerical calculation. So, dimensional homogeneity. So, from word itself, no? The dimension should be homogeneous or isa lang. Each term must be represented in the same units. If this is the case, the element of equation will be merged into a the variables are replaced by numerical values. So, yun nga, dapat yung dimensions mo iisa lang. So, yun, nakat kasi yung video sa part na yun. So, itigil tayo sa dimensional na mobility. So, dapat, for yung dimensions mo, units, sa pag-solve kasi pag iba yan, iba na yung magmamali, like meter or feet, yung pag-times mo, pag-add, so mali na yung sagot mo. Okay, so rounding of numbers, it is important to round off numbers such that the precision of the answer is the same as that of the data on the query. Any numerical statistic resulting in a number greater than 5 is rounded up as a general rule, and no number less than 5 is rounded up. So, sa atin naman, hindi naman tayo nag-round up. I-store lang natin, no, sa calculator natin. So, okay din naman yun na mag-round up, but for us, no, para ma-preserve yung accuracy ng sagot natin, doon na lang tayo mag-round off, no, sa final answer natin. So, calculations, no, dito rin, sinabi din sa calculations, no, na yun nga, sa final answer na tayo mag-round off. So, we will usually complete the answer to three significant figures since most details in engineering mechanics, such as geometry and loads, can be calculated accurately to this precision. Pero sa atin nga, sabi ko lang ulit, no, yung sagot, hanggang hindi ka pa nandun sa final answer, huwag mo siya nilang okay? So to preserve the accuracy. And then, next, so may learning activity din, sasagutin nyo. And then, scalar and vector. So scalar is any positive or negative measurable quantity that is entirely specificable, no, or specifiable by magnitude. So sabi, examples of scalar quantities includes time, length, and mass. So vector is a physical quantity which needs a detailed explanation of both magnitude and direction. So dito no sa ano natin sa pinakaiba ng scalar and vector, scalar is yung magnitude lang, then vector is magnitude with direction. So kung naalala nyo, no, yung differentiation natin ng scalar and magnitude natin. So, scalar and vector, yun lang yung pinagkaiba nila. Scalar, magnitude, while vector is magnitude with direction. So, yun lang yan, no? Kasi actually sa module yung marami pang nakasulat dyan. But it's the concept or kumbaga direct to the point. Then, ito, sa picture na to, meron tayong component at x, of course, component at x, of course, at component y, in the y-axis, and we have resultant force. Okay, so procedure for analysis. So parallelogram law, no, two component forces F1 and F2 add in accordance with the parallelogram rule, yielding the resulting force FR or your for a resultant force which forms the parallelogram diagram. So kapag pinag-add mo daw yan, no, through ng F1 na F2 mo, makuha ng FR. Same with other forces. No? So, if force F is to be fragmented into components along two axes, U and V, no? So magkaibang axis naman, no? Start to the head of force F and create lines parallel to the axis, thereby creating a parallelogram. The parallelogram side shows the elements FU and FV. So, parang mag-create ka lang ng four sides mo, which is equal, no, sa side mo. So, yun na yung parallelogram rule. Kumbaga nag-intersect ka. Hanggang ma-reach mo yung force mo or yung diagonal. Okay? Sa ano yan, no? Sa four sides, no? Or four sides or four edges. Parallelogram law. So, trigonometry natin, no? Magkakaroon lang tayo ng triangle sa loob na parallelogram natin. So, the magnitude of the resulting force can be calculated from this triangle using the law of cosines. And its direction is calculated with the law of sine. The magnitude of two components of force are determined by sine's law. Okay? The formula are shown in the figure. So, ito yun, no? So, from galing na siya sa basic trigonometry natin, no? Cosine law and sine law. If you remember, no? So, sabi dito, parallelogram law, C is equals to A plus B. Okay, ito dyan. While sa triangle law mo, C is equals to A plus B. Okay, so same lang din, no? Dito sa diagonal sa parallelogram law, while sa triangle mo, dito ang hypotenuse. And solving, no, sa ano natin, sa angles, galing na siya sa cosine law and your sine law. Okay, so basic trigonometry. So we have here, no, formulas ng sine law tsaka ng cosine law. Pero gamit lang naman natin dito is itong sa C, yung hypotenuse. Pero okay lang din naman na gamitin yung iba dyan. Pero yung sa indication na natin dito sa formula, yun yung ginagamit. Since direct lang siya sa hypotenuse mo. No? Pero kung saan kayo sanay guys, ko sa tama yung sagot yung tama yung process, makikita ko naman yan. Okay? So, example tayo dito sa yung screw eye natin subjected to two forces. We have F1 and F2 determine the magnitude and direction of the resultant force. So, the parallelogram is formed. We draw a line from head of F1 that is parallel to F2 and another line from head of F2 that is parallel to F1. So, the resultant force extends where these lines intersect from point A. No? At point A, dito, um, the two unknowns are the magnitude of FR and the angle theta. So, i-draw na natin dito yung free body diagram natin. No? So, dito sa gilid. No? So, copy natin siya. Lagyan natin siya dito sa pen para mamaya ma-explain natin, no? Kung anong mangyayari. And then, no? From the parallelogram, the vector triangle is constructed using the law of cosine. So, sa cosine law, i-input na natin yung value natin. So, sabi dito, we have your A, which is this one, no? F1 mo, F1, F1, which is equals to 100 Newton, 100 Newton nyo, and then your F2 will be, which is 150. So, designate lang tayo dito, no, guys, ng ating mga value. Okay, which is 150 Newton. And then, para natin nakuha yung mga angle dyan. Kasi dito sa cosine C natin, nilagay ng 115, which is nilagay dito sa ating given na diagram. So, para nakuha yung 115 dito, simply, na-given ka ng 10 degrees sa y mo, itong y, and then, you have 15 degrees sa x mo. Okay? 10 degrees. So di ba sa right triangle natin, meron tayo 90 degrees. Okay? 90 degrees. So, 10 plus 15 is 25, tapos minus mo na sa 90. So, makita nyo sa baba, no? Dito, 90 minus 25 equals to 65. So, assume natin, na-assume, nakuha na natin yung angle natin sa loob, which is 65. So, magkabilaan siya, no? Which is under the parallelogram rule. So, pareho sila ng sides, pareho sila ng angle. So, di ba sa parallelogram rule, ay parallelogram na shape natin, we have 360 degrees. Kasi sa triangle natin, meron tayong 180. So, times lang natin sa dalawa yung 65 from edge to edge, no? Pamaisin natin sa 360. So, 360 minus, no? Sa 2 times 65 mo, meron kang 230. So, 230, 2 yan guys sa baba, kasi may divide mo sa 2 yung dalawa. So, 230 divided by 2, mag-isip mo lang, you get 115. So, yun yung 115 mo dito guys. 115 here, 15, and 150 plus mo. So, input lang natin yon sa cosine law, we'll get 230 Newton. So, basic lang, di ba? And then, applying the law of cosine to determine the theta. So, di ba sa 150 natin, sa triangle natin dito, so dito tayo mag-focus isa. Gets na din dito sa sa resultant force. So, dito tayo sa delta. Di ba nagka-correct na tayo? Alam na natin yung sign of natin. So, basic sign law, which is, alam na natin yung A natin, no? Which is 150 Newton. So, A over sin theta equals to your D, your C. No? Kung anong sides man yung gusto mong malaman. No? Kasi ito yung A natin, di ba? So, yung B, yung C. So, ito yung kinukuha natin, no, guys. Yung P natin from your Y. Okay? Kasi din yung direction niya, di ba? So, C over sin theta. No? So, substitute mo lang yan, no? AC, dito, from your, itong picture na to, sa left side ng screen, yung presentation. So, 150 Newton, itong A, no? Itong A, ito natin na color, di ba? Sin theta, kasi ito yung hinahanap mo, h dito. And then, this was to 212.6 Newton, which is yung resultant, no? Nakuha mo yung resultant mo. Inano na natin yan, simple, round off, no? So, kasi yung nakalagay sa modules, no? Pero kapag, ano yan, apat sana, apat point something. Then, sin 115. So, transpose lang. Then, arc sine para makuha yung 39.8. Okay? So, yun yung theta natin dito. So, the direction of phi of f measured from the horizontal is, sorry guys, hindi pala to y. It's x. Sorry. Yun yung ako sa hindi. So, x yan. X kasi yung taas mo y. So, sorry for misconception din yung sabi ko. So, x, y, no? From the horizontal is 39.8 plus 15, which is equals to 54.8. Kasi nga, given ka ng 15 dito, nahanap ko yung angle ka dito na given, or yung nakuha mo dito sa sign mo. So, i-add mo lang yun, no? Yung 39.8 plus 15 kasi yung angle mo, or yung resultant force mo, no? Measured from its horizontal. Okay, kumbaga yung reference line mo kung saan siya umangat yung resultant force. Okay, so yun lang. Next is your solving resultant forces. So by solving resultant forces, find the x and y factors of all the forces. So summation of forces ng force at x-axis mo and summation of forces mo sa y-axis. Then using Pythagorean theorem to get resultant force na F or equals to square root of your resultant force at x squared as resultant force at y. So, kita na dito. Then, use trigonometric function to get the angle resultant force. So, galing siya sa Pythagorean theorem, the resultant force, and sa katawa, which is yung tawa. Tan theta lang ito, di ba? So, tawa is tan theta equals your y over your x. Okay? Excuse me. And then, solve tayo dito. Solution 1, no? So, this is our figure. Kunin natin summation of forces niya. Divide pa natin, no? So, summation of forces at your x and summation of the forces at y. So, simply, no? Summation of forces at x is equals to 600. No? 600 dito sa part na to. 600. So, 600 yung F1 mo. Here is F1. 1, which is 600, times the cosine 30. Is, nabibis kasi yung x-axis. Axis mo, yung x-axis mo, minus cosine, cosine, minus 400 sine 45, which is here. No? For tulad ng force. Solution forces mo yan, isipin mo lang sa solution forces mo, sine 45. Since, harap dito, yung forces mo. Yung force mo na x. So, 400 sine 45. Okay? So, dito yun ha. Nakikita yung mouse ko. Kaysa na isulat ko pa dito kasi naka-paint na yung isulat. So, yun yung makuha mo na yung resultant force of x. And then, ulitin natin sa y. We have 600 sine. Since, yung sine mo ito, yung y mo to, yung x mo kanina, so kaharap, sine 30 Newton plus, ay sa dito pala minus kasi nga, dito sa fx, sa force ng x mo, minus yan kasi nga, paleft yung force mo. And then, dito naman, lahat sila positive kasi nga, yung x sa x mo, sa y mo, lahat sila pataas. Ito pataas siya, and then ito din, pataas here. Kaya, nag sine 30 Newton, and then 400 cosine 45. So, yun nga din, may narinig ko dyan kung ano ang katapat at kung ano ang kaharap ng sine. So, simple lang guys. So, referring to your uh, y. So, kung kayo namatala sa angle, kung anong ang theta man yun, kung kaharap ko yan, sine, kung katabi mo, fx. Okay? Yun yung x and y component mo. Yun nga, may nagtanong sa akin, no, na kung may sinabi ako na yung cosine daw is, sabi ko lahat ng x cosine, lahat ng y sine. Actually, style ko lang yun sa paggamit. Pero mag-iiba yan guys if iba yung given mo. Ibang sagot yan. Dito na kasi, in case na dito, yung sine 45 or cosine 45 is the same na sagot. No? Pero, yung sa akin kasi, nagre-refer ako sa cosine lang ng x para hindi ako malito. Kunyari, no? Dito sa, kunyari, iba yung given mo. You have here, kunyari, example is, practice ka dito, y into x. So, given ka dito, ay, process ng 1, 2 mo. Ito sabihin natin f2 to, no? And, f1 mo to. Nilagay ako dito, kunyari, 30. 30. Ito. Tapos, kukunin ko yung x and y component niya. No? So, di ba fx mo yan? Kasi nga, horizontal, then ito yung vertical mo. Y, or sa gilid mo. So, dito, di ba yung fx mo dapat sine siya kasi kaharap. Pero kung gagamit ka ng cosine, guys, dapat sa baba na reference ka na angle, which is 60. So, kapag tinayin yan sa calculator niyo, no, fx cosine mo, yan ang sagot. Okay? So, dito kasi 45 yan. So, kahit 400 sine 45 or 400 cosine 45, same yung sagot niya sa 236.8. So, sa akin kasi, lahat ng x ko gusto ko cosine. Then sa lahat ng y ko is sine. So, huwag lang kayong malito doon. Mas isipin nyo na lang yung kaharap tsaka yung katapat, no, ng angles mo. Kasi narito siya dun sa axis, dun sa kung ano yung kaharap at katapat. So, yun yun, diskarte nyo naman yun, kung ano yung gusto yung reference. Kung sa akin, sinabi ko lang yung style ko. At sa inyo, na sa inyong mga students, ano na lang, better na lang kayo dun kung ano yung kaharap niya, side, katabi, is cosine. O hindi kayo malito. Okay? So, sa ano nga, yung sa nakuha na tayo, nakuha na natin yung resultant versus mga x, resultant versus that y, yung gagamit tayo ng Pythagorean. So, ito na yung nakuha natin. No? So, Pythagorean theorem, input mo lang doon, no? For first ng x mo, kasi di ba, c squared equals to e squared plus b squared lang, di ba? So, ano mo yan, c equals to square root of your b squared plus b squared. Okay? So, yun lang din yun. Makakuha mo yung resultant force mo, and then, your theta lang. No? Your TOA, which is, TOA is simply your, okay, i-edit ko natin dito. So, ayun, no, makukuha na natin yung direction ng resultant force mo by your TOA, your tan theta equals to your y, yung opposite for your x. So, saan yan? No, yung 67.9. So, pay tayo ng x mo axis natin. Okay, so x, this is your y. So, di ba, given tayo ng, nakuha na natin yung second force natin sa x-axis, which is 136.8 Newton. So, papunta dito no, sa ating right. Right. Or x. And then, we have force at your y-axis. Resultant force at y-axis, which is 582.8. So, mga dito. So, okay. Then, our x resultant force sa y-axis. And then, nakuha natin yung resultant force natin, which is 629 newtons. So, dito yan. F, R. So, yung angle na makukuha natin dyan, dito yan, dito yan. Ayun. Mga pwesto ng data natin from your x-axis. Kasi nga, we have, nakuha na natin yung resultant force natin ng x and y. So, dito yun, yung 67.9. So, gets po guys. So, yun lang yun, no? So, basic lang na pagkuha ng resultant forces and yung direction lang. So, sa module 2, mas complicated, no? Since mas marami siyang topics na yung lesson natin. So, pagkatapos ng module 1, i-upload mo sa module 2 nyo. Okay? So, basic concepts lang ito na parallelogram law, cosine law, sine law, and your Pythagorean theorem. And yours, so, yun ang module 1 natin. So, good luck na. Kung may questions kayo or concerns, sabihin nyo lang sa akin. Kung ako sa mag-reply sa mga message nyo. Thank you. No? So, kung may clarifications, kung na kayo may isa. Okay? So, thank you guys and good luck.